This conference will now be recorded.
Fine. We'll try to understand Power Pivot. Power Pivot is a database where we will create an OLAP model. So database. What is the purpose of database? Database. Database is
Storing
used to store the
storing
data
the
in the form of data. Yes,
uh,
correct. Database is
rows.
used to store the data. How we will store the data in the database? In the form of tables. In the form of tables. Database used to store the data in the form of tables. Okay, database will store the data in the form of tables. How Oracle and SQL Server are databases, this Power Pivot is also a database. In the Power Pivot, we will store the data in the form of tables. As Power Pivot is a database, the core functionality of database is to store the data in the form of tables. To store the data in the form of tables. Okay, so this is not a normal database like SQL Server or Oracle. In the software field, there are two types of databases. One is relational databases. Relational databases, we also call it as traditional databases. And second one is in-memory databases. In-memory databases. In-memory databases, there are two types of databases: relational databases and in-memory databases. Example here, SQL Server or Oracle, Oracle, etc. etc. comes under relational databases. And in-memory databases, SAP HANA, Power Pivot, SAP HANA, Power Pivot, SAP HANA, Power Pivot, Power Pivot will comes under SAP HANA, and Power Pivot will comes under in-memory databases. Power Pivot will comes under etc. etc. There are other softwares also comes under in-memory databases. So when it comes to in-memory databases, they are powerful when it comes to reporting, guys. So the same data what you are storing in SQL Server, you can store in Power Pivot also. So take an example. In SQL Server, I have some data. I'm creating the reports on SQL Server. I'm creating a report on SQL Server. Using the data, I'm creating a report. When I share that report with my clients, when my client open that report, it will take some time to see the data in the report. Let's take an example. It is taking 60 seconds of time. So it contains some huge volumes of data. When I create a report on huge volumes of data, when I share that report with my client, every time when my client open that report, it is taking 60 seconds of time to show the data in the reports. That means this report will fetch the data from source. It will try to show it in the report. For that, it might take some time. So same data, whatever you have in the SQL Server, the same data is there in the Power Pivot. And same report I created on Power Pivot this time. Same report, whatever I created here, same report I created here on top of Power Pivot. And I share the same report with my clients. When my clients open this report, they can see the data within 10 seconds, around 10 seconds of time. So here, same data, same report, 60 seconds. Same data, same report, they can see in 10 seconds. That much performance you can see. So how that much performance we can gain using Power Pivot? So this is because of the architecture of the database, case, the behavior of the database. So in-memory databases will give better performance when it comes to reporting, guys. So in-memory databases will give better performance. I'll explain. The in-memory databases will give better performance when it comes to reporting when compared to so when we do reporting on in-memory databases, they'll give better performance when we do reporting on in-memory databases. They'll give better performance when compared to
Relational.
relational databases, when compared to relational databases. How? So I'm telling that, so when you are doing the reporting on in-memory databases, they'll give better performance rather than relational databases. How? So let me explain how it will happen. So when you access the data from relational databases will process the data from where? It will process the data from hard disk. When we access the data from relational databases, when we access, yes, HDD, hard disk it will give. When we access the data from relational databases, they will process the data from hard disk. From hard disk. But when you access the data from in-memory databases here, the same thing when you do it, when you access the data from in-memory databases, they'll give it from RAM. In-memory databases, they will process the data from RAM. RAM is tens of times faster than hard disk. When you take the data from RAM, it is tens of times faster than hard disk. That is one reason why you are able to see the data in the reports quickly. When you do the reporting directly on top of a Power Pivot, that is how you can see the data quickly. As when you open a report, every time the data will be processed from RAM. When we take the data from RAM, it is much faster. It is much faster. Okay. So there are some more advantages with in-memory databases, guys. The architecture of relational databases is completely different. The architecture of in-memory databases is completely different. So in relational databases, data will be stored in the row format. In relational databases, data will be stored in the row format. But in in-memory databases, the data will be stored in the columnar format. In in-memory databases, data will be stored in a columnar format. I'll show you what is that. In in-memory databases, data will be stored in columnar format. You will understand what is row format and what is columnar format. When we store the data in the columnar format, you have few more advantages. So as it is processing the data from RAM, we can retrieve the data faster. In the same way, we're telling that in relational databases, data will be stored in row format, and in memory databases, data will be stored in columnar format. When we store the data in the columnar format, we have some more advantages. So the first advantage when we store the data in the columnar format is data will be highly compressed. When we store the data in columnar format, we have some more advantages. What are the some more advantages is data will be highly compressed. Data will be highly compressed. So when we store the data in the columnar format, the data will be highly compressed. Highly compressed means the data size will reduce. Compressed means data size will reduce or increase. It will reduce. Look at this. When you have a SQL Server database, when you store some data here, if it is occupying 100 GB space, to store some data in the SQL Server, it is occupying 100 GB space. The same data, I bring it to Power Pivot, I try to store it here. It will occupy only 10 GB space approximately. Same data, when you store it in SQL Server, it is occupying 100 GB space. When you bring it into the Power Pivot, it will occupy just approximately 10 GB space. Almost 90 GB space you are saving. What is happening? So why it is occupying very less space is because of columnar format. So when we store the data in the row format, it will occupy more space. I'll explain. When we store the data in the row format, it will occupy more space. When we store the data in the columnar format, it will occupy less space. Columnar format, it will occupy less space. less space. How? We'll discuss. So let me write here. We are telling that data will be highly compressed. So when SQL Server contains 100 GB data, 100 GB data, when you load the same data into the Power Pivot, it will come to approximately 10 GB. So you can mention 1/10 of source data. Power Pivot will compress the data till 1/10 of source data. It is 1/10 of source data. 1/10 of source data, approximately 1/10 of the source data. So how it is happening is because of columnar format. Here, so let me show what is that row format and what is that columnar format. What is that row format and what is columnar format? Let me show you. What is that row format and columnar format? Let me show you. Fine. So there is one table, employee table. The table contains employee name, 4 columns. This is the table. Ignore this. Row storage, ignore this. There is a table, employee name, 1 column, job, another column, salary, another column, department, another column. So this is employee table. I want to store this employee table in the SQL Server or a relational databases. Not only SQL Server, relational databases. When we store the table in the relational databases, I'm telling that it will store the data in the row format. So what it will do is it will take first row. First it will store the first row. So once it is done with first row, it will take second row. Then it will store second row. Then it will take third row. Then it will store third row. Then it will take fourth row. It will store fourth row. Then it will take fifth row. Then it will take sixth row. It will store each row, fourth row, fifth row, row by row it will store. When it stores the data in the row format, we cannot compress the data. There is no chance of compressing the data. So there is no chance of running the compression algorithms. There is a concept of compression algorithms which will help us to reduce the data size. So when we store the data in the row format, it is not possible. Why? Because when we take each row data, each row might contains different data type data. So this is a text data. This is text data. This is number data. This is numeric data. And each block contains different data type data. So each row contains multiple columns and it contains different format data. Sometimes text, sometimes numeric values, you'll get it. Sometimes date values also. When you have different data type data, it is not possible to run the compression algorithms there. There is no possibility to run the compression algorithms here. When there is no possibility to run the compression algorithms, it will take more space. So in each block, it is storing different data type data. There is no chance of running the compression algorithms here. When we store the data in the row format, that is the reason it will occupy more space. But when it comes to here in the in-memory databases, so same employee table, the same employee table with same columns, same employee table. So when we store in in-memory databases like Power Pivot, it will store in columnar format. What it will do is it will take each column first and it will store that column data here, and it will take next column. It will store next column data. It will take next column. It will store, and it will take next column. It will store column wise. It will store. So when we store the data in the column wise, a block might contain same data type data. If you see in the block 1, you will have completely text data. In this block 2 also you have completely text data. In the block 3 you have completely number data, numeric data. When the block contains completely same data type data, there is a possibility to run the compression algorithms. So here we can run the compression algorithms. What that compression algorithms will do is they will reduce the data size. So when you run the compression algorithm here, for the first time clerk is coming, For the first time clerk is coming, for that clerk it will assign an ID called 1 or some ID, not only one, any ID. So it will assign one ID 1. Take an example. So from second time when clerk is coming, it will not store complete clerk. Instead of storing complete clerk, it will store 1. Already when clerk is coming for the first time, it given ID 1. From the second time when clerk is coming, instead of storing complete clerk, it will store 1. Instead of storing complete clerk, it will store 1. See how much space it is saving. When you want to store clerk, it will occupy more bytes. When you want to store 1, it will occupy less bytes. When you run the compression algorithm, for the first time analyst is coming, it will give one ID. Let's take 2. From the second time when analyst is coming, it will not store complete text. It will store with 2. It will store with 2. Instead of storing with complete analyst, when you store with 2, it will occupy less space. So this compression algorithms, when we can run is when you have same data type data. So we can run the compression algorithms. When you run the compression algorithms internally, something it will do. So like this, for some text, it will give an ID. Next time when the same text is coming, it will not store with the complete text, it will store with the ID. So instead of storing complete text like this, if you store a small ID, it will occupy less bytes. That is the reason it will reduce the space. It will reduce the space. Here also, when you bring any table, I have a table here. So when I bring the table to Power Query, when I load it to Power Pivot, in the Power Pivot, so when the table is taking 1 GB of space or 10 GB of space here, when I load the 10 GB table here, it will come to how much size? 1 GB. There is a table with 10 GB space. When I load it, it will come to 1 GB. As soon as you click on load, once you bring the table, once you transform the data, once you load it, in the back end, the compression algorithm will execute and it will compress the data and it will store the data in its own format, which will reduce the size. So I said it, when we are storing the data in the columnar format, there is a possibility to run the compression algorithms, which will reduce the size. Here in Power Pivot, which one will run it? So when you extract the data from data sources, when you transform the data in the Power Query, when you load that data into the Power Pivot, there is a engine called XVelocity engine, which will come into the picture and which will compress the data. So let me open course content here once. So in the Power Pivot, we have one engine with the name, so XVelocity in-memory engine. So previously they call it as Vertipack engine. In Power Pivot, which software will compress the data is Vertipack engine software. Internally in Power Pivot, there is one software with the name Vertipack software. Vertipack software. So then that Vertipack, when you load the data into the Power Pivot, this Vertipack software will compress the data and will store the data in its own format. They will ask in the interview, what is Vertipack software? The older name is Vertipack. Now they got renamed this Vertipack software to XVelocity in-memory software. So this XVelocity in-memory software will compress the data and will store the data in the own format. Let me write here. When you extract the data from any data source, when we extract the any source, transform the data, and when we loads the data, when we extract the data from any source, transform the data, and when we loads the data into the Power Pivot, when we loads the data into Power Pivot, when we extract the data from any source, transform the data in the Power Query, and when we loads the data into the Power Pivot, a Vertipack engine will come into the picture. When we load the data into the Power Pivot, so a Vertipack engine, as soon as you start loading the data from Power Query to Power Pivot, a Vertipack engine will come into the picture, and that Vertipack software will compress and will store the data in its own format. Who is that? Anybody have any questions? Someone unmuted here. Please be on mute. So when we load the data into the Power Pivot, Vertipack engine software will come into the picture. Well, Vertipack software, which is where it is available. Vertipack software. Vertipack software is available in Power Pivot. Vertipack software will compress and stores the data in its own format. Compress the data and stores the data in its own format. So now the name is not Vertipack software. Vertipack software is the old name. The current name Vertipack is the old name, and the Vertipack name there. This is the old name, guys. They will even ask what is Vertipack software. So Vertipack is one of the software available in Power Pivot which will compress the data. This is old name. So they might even ask what is X velocity. X velocity in memory. X velocity in memory software. The recent name is X velocity in memory analytics engine or X velocity in memory software. You can call it with any name, guys. So this, what is this X velocity in memory engine? They might ask you. So this is the new name. So this X velocity in memory engine will be available in Power Pivot, which will compress the data. It is the new name. In any interview, so when they ask whether Vertipack, when they said that whether it is Vertipack or X velocity in memory, you need to tell that that is a software which is internally available in Power Pivot, which will take care of compressing the data and storing the data in its own format. In which format the data will be stored in Power Pivot? In a columnar format. This is how the data size will reduce, guys. I shown you here. So as it is storing each column's data in one block, we can run the compression algorithms. That compression algorithms will help us to reduce the data. So where which software will run them? Vertipack software or X velocity in memory analytics engine software will do that. Fine. This is one advantage. So with by storing the data in the columnar format, there is one more advantage. The second advantage when you store the data in the columnar format is, so when we do the aggregate calculations, it is much faster, guys. In columnar databases, aggregate calculations are much faster. Let me write. When in columnar databases, when we perform aggregate calculations, they are much faster. When we perform aggregate calculations, they are much faster. So in columnar databases, when we perform aggregate calculations, they are much faster when compared to row databases. What is the meaning? I'll explain. Row databases. In columnar databases, when we perform aggregate calculations, they are much faster when we compare to row databases. Take an example. In my SQL Server, it's a row database. We call it as a traditional databases, relational databases, or row databases. Why? Because it will store the data in the row format. When we perform any aggregate calculations here, it might take some time. When we do the same aggregate calculations in columnar databases or in-memory databases, they are much faster. So I have a sales table. That sales table contains 100 million records. 100 million records. So when you have 100 million records, when you perform sum of sales here, let's take an example. It is taking some 15-20 seconds of time. Let's take it is trying to give the result in 20 seconds of time. From 100 million rows, when you want to perform sum of sales, it is taking 20 seconds of time. Just I'm roughly giving one number, guys. The same sales table is available in Power Pivot, and same 10 million records are there. When you perform aggregate calculation sum of sales here, it will give the data within 5 seconds of time, less than 5 seconds of time, around 5 seconds of time. So here, why it will take 20 seconds of time? Here, how can you give it within 5 seconds of time? So how can it do? So reporting is all about aggregating the data. So when you talk about reporting is about aggregating the data. Count of orders is aggregating the data. Sum of sales sum of profits, count of customers. Reporting is all about aggregations. When you perform any aggregation calculations on Power Pivot, they are much faster when you compare to the raw databases. How means? Look at this. So here, when in raw databases, I have a salary column and I want to get this data in the raw databases. It will store like this. It will store like this. So I want to get sum of salaries we are paying. I want to calculate sum of salary. Sum of salary is an aggregate calculation. I have a salary column. So that salaries we are storing like this. So in the row databases, first row we will store it in the first block, and then second row, and then third row, and then fourth row, and then fifth row, like this, right? I want to get sum of salary from this row storage. When you want to get sum of salary from row storage, I want to go to each block. I want to collect the salary. I want to go to this block. I want to collect the salary. I want to go to another block. I want to collect the salary. I want to go to another block. I want to collect the salary. I want to go to another block, collect the salary. Going to each different place, collecting the salaries might take time, and then we need to sum them. So that is the reason it might take time. But when it comes to columnar storage will store in columnar format. So all the salaries you have in one place. When I want sum of salary here, same sum of salary, I don't want to go and collect the salaries from different places. All the salaries are in one place. I can do it sum. This is the reason when you perform any aggregate calculations on columnar databases, they are much faster. They are much faster. We don't want to go here and there. We don't need to bring the data. On the whole, Microsoft developed this Power Pivot software only for reporting, purely for reporting. So totally three advantages. As it is processing the data from RAM, it is much faster. As it stores the data in the columnar format, we can compress and the data size will reduce. Second advantage. The third advantage is when you perform any aggregate calculations, they are much faster when compared to raw databases. I've shown you practically here. So on the whole, in Power Pivot, so when you load the tables into the Power Pivot, you will see the tables how it looks in the SQL Server only. How it will looks in the SQL Server, same way you will see. But I'm talking about internal mechanism, backend architecture. In the backend architecture, we are talking about it. So that is the reason. What we need to do better, we can do the reporting on Power Pivot database, guys, right? So Power Pivot, when you do the reporting on the whole, first I written one point. When we do the reporting on in-memory databases, they'll give better performance when compared to relational databases. So whatever I discussed from last half an hour, nothing to do as a developer. Whatever I discussed from last half an hour, nothing to do as a developer. So why I explain is you'll get few interview questions here. What is VertiPack engine, or what is XVelocity in-memory engine? Or so when you load the data into the Power Pivot, till what extent it will compress the data? So if you don't know all this, you cannot explain to the interviewer till what extent it will compress the data, 1/10 of source data. And VertiPack engine is the software which will compress the data, or XVelocity in-memory engine is the software which is there in Power Pivot, which will compress the data. Fine. So as a developer in Power Pivot will perform two activities, guys. As a developer in Power Pivot will perform two activities. One is data modeling. Second one is enhancing the data model. So once you load the tables into the Power Pivot, so once you bring the tables, transform the data, once you load the tables in the Power Pivot, as a developer will perform two activities. One is data modeling and second one is enhancing the data model. So you need to understand what is this data modeling, why we need to do it, what is this enhancing the data model, why. So Power Pivot is one of the important module for a Power BI developer, guys. You are constructing a 100 floors building. So for a building, how base is important. So for all the reports and dashboards, when you are building here, so the data set is that much important. So or the OLAP model is that much important. So here We'll talk about data modeling concepts for 5 hours of time, and we'll talk about enhancing the data model for 12 hours of time. So enhancing the data model is the place where DAX will come into the picture. DAX will come here. DAX will be discussed for 12 hours of time, and data modeling part will be discussed for 5 hours of time. Both are important. Both are important. Right. First, let me start with what is data modeling. Let me start with what is data modeling and how we will do the data modeling. From now, for a couple of days, we'll discuss about data modeling. 5 hours. First, let me give the definition of data modeling. Establishing the relationship between the tables. Establishing the relationship between the tables. The relationships between the tables we call as data modeling. We call as data modeling. Establishing the relationship between the tables. Let me open Power BI desktop, and I join for one company. That company is storing the data in the SQL server. That company is storing the data in the SQL server, and they're asking to create some reports and visuals on top of it. You need to bring the data. You need to bring the data. You need to transform the data. You need to load the data into the Power BI. Once you load the data into Power BI, you need to do data modeling here. Let's see what is that. So I open Power BI desktop. Just close this. Click on transform data. How to open Power Query? Go to home tab, click on transform data, and bring the tables where your company is storing the business data. New source, click on SQL server. My company is storing the data in the SQL server. Let me go here, and let's give the server name and database name here. So I'll copy the server name. I'll give the database name here. I'll copy the server name. This is the server from where I need to bring the data. This is the server. Copy the server. Let's provide the server name here, and let's provide the database name also. So database name is optional. And you press OK, it will open that server. It will show the list of databases. Expand any database, bring the tables. Customer data table, or product data table, or sales data table. So whatever the tables you need for analysis, you need to select them. You need to select them and press OK. If you want, you can even bring the timetable. For now, let me bring only these 3 tables. Press OK. So if required, go and transform the data in the tables. Go and transform the data in the tables. So if you want to convert the product name to uppercase or any transformation required, we can do it. Once we are done with transforming the data in the tables, we can load the tables into the Power BI. We can load the tables into the Power BI. Okay, guys. Before we load the tables into the Power BI, so let me bring some more tables from Excel. My client is not only storing the data in SQL Server, he is storing some more data in the Excel. He's asking to analyze both the data together. SQL Server data he's asking to analyze, even Excel data he's asking to analyze together. So let me connect to Excel. Let me bring some more tables. Just let me bring some more tables from Excel into Power Query. How can we bring some more tables from Excel? Click on new source, click on Excel. So browse where the Excel files are located. So I want to bring it from this Excel, EMP, DEPT and managers table. Click on open, select EMP table, DEPT table and managers table. Click on OK. Click on OK. When you press OK, the tables will come to Power Query. If you want, you can even transform the data in these tables. Once you are done with transforming the data in all the tables, we can load it. When I click on close and apply, the tables will be loaded into the Power BI. When you try to load the tables into the Power BI, the Vertipack software or XVelocity in-memory software will come into the picture. It will compress the data in all the tables and it will store the data in its own format. In its own format. Click on close and apply. Click on close and apply. When I click on close and apply, the data is loading into the Power BI, guys. The data is loading in the Power BI. Look at this. It is loading the data in the Power BI. So it got loaded the data. Fine. So let me click on this. It got loaded the data. And when you load the data, we are telling that we need to establish the relationship between the tables. We need to establish the relationship between the tables. So we need to do data modeling. Data modeling is nothing but just having the relationship between the tables, guys. If you see, between customer data table and sales data table, you have a relationship. Between sales data table and product data table, you have a relationship. So this relationships, establishing these relationships, we call it as data modeling. But when you load the tables into the Power Pivot, the majority of the data modeling work will be done by Power Pivot itself. So once you load the tables, I'm telling we need to establish the relationship between the tables. So this work, majority of the work will be done by our Power BI itself, or Power Pivot itself. When we load the tables into the Power Pivot, load the tables into Power Pivot, majority of the data modeling work, majority of data modeling work will be done by Power Pivot itself, guys. Will be done by Power Pivot, done by Power Pivot itself. Power Pivot itself. Power Pivot itself will do majority of data modeling work. Yes. So first of all, once you load the tables, why we need to do the data modeling? So even though when my Power Pivot is doing the data modeling work, or when my Power BI is doing the data modeling work by itself, we need to learn every data modeling concept, guys. Data modeling concepts are important. So you cannot blindly trust the data modeling what Power BI is doing automatically. Sometimes it might do only 70% of data modeling work. You might need to go and do remaining 30% of data modeling work. Sometimes it might do 90% of data modeling work. You might need to go and do remaining 10% of data modeling work. Sometimes it might do 100% of data modeling work also. You might need to check whether it is doing that work correctly or not. As a developer, you need to have the knowledge whether the data modeling which Power BI is doing is correct or not. Is correct or not. First of all, okay, first, what is data modeling? Why we need to do the data modeling? Simple question is, so we understand what is data modeling. Why we need to do the data modeling? I already discussed in the introduction classes why we need to do data modeling. Do data modeling. Why we need to do data modeling? What is the need? Or what is the need of establishing the relationship between the tables? The same question. What is the need? Need of establishing the relationship between the tables? For both the questions are same, they're asking in a different way. The meaning of the question is same, they're asking in a different way. The answer is, so why we need to do the data modeling is, when you load the tables, so all the time client will not store the data in single table. So when client is storing their business data, they all the time they don't store all the business data in single table. They might store some business data in one table, they might store some other business data in another table. So right, when client is storing their business data in multiple tables, sometimes we might need to create the visuals. Client will ask you to create some visuals where we need to show some data from DEPT table, where we need to show some data from EMP table. So as client is storing their business data in many tables, so when you join in the company as a employee, some employee details will be stored in employee table, some employee details will be stored in DEPT table. That means only employee information itself they are storing in two different tables. Employee information itself. And sometimes they'll ask you to create the visuals to show the data from this EMP table and DEPT table together in the visuals. Whenever you need to create a visual using this EMP table and DEPT table, mandatorily you need to have a relationship. If you don't have the relationship, visual will not show the data. Visual will not show the data. Here, whenever we need to create the visuals on more than one tables, we need to have the relationship between them. Whenever we need to create visuals using more than one tables, using more than one tables, we need to have the relationship between them. We need to have relationship between them. Between them. When you have the relationship between them, Whenever we need to create visuals using more than one tables, we need to have relationship between them. When you have the relationship, then only we can show the data in the visuals. So when you don't have, it is not possible to create the visuals, right? Here I want to create the visual using EMP table and DEPT table. So when I join in the company, EMP table is storing some employee related information. So when you join in the company, they'll give one employee number. What is your name? What is your designation? Who is the manager for you? On what date you join the company? What is the salary they're paying? Commission? And in which department number you are working? And the same employee Clark is working in which location? In working in which location? Working in which department name? Department name. The same employee Clark working for which department? He is working for accounting or he is working for sales. Which department name is storing in another table? This Clark is working in which location? New York or Dallas? They're storing in another table, guys. So in the visual, client is asking to show employee name. In a visual, client is asking to create one visual where they're asking to show employee name. Employee name, you can drag it from employee table. Beside the employee name, they're asking to show client is working in which location. This employee is working in which location. Client is asking to show, can you show me employee name? Clark. And Clark is working in which location? I want to show here. Where do you have location column? Do you have in EMP table? No. Location column is there in the DEPT table. You want to drag the location column here. So that means we want to drag the columns from two different tables in this visual. When you want to show this, I want to show employee name and in which location that employee is working. So I want to show employee name and in which location employee is working. I can go to the employee table. I can drag the employee name columns. For every employee, it will show the names. And along with this, I want to show in which location they are working. Adams is working in which location. When I want to show Adams is working in which location, so location column is available in DEPT table. I want to show it. So we will delete this relationship now. We'll delete these relationships. We'll go and drag location here. We'll go and drag location here from DEPT table. When I drag the location, the visual will not show the data. So you are taking the columns from EMP table as well as DEPT table, and the visual is not showing the data. The problem is when I click on see details, it will tell that cannot determine the relationship between the fields. So there is no relationship between these two tables. We are not able to see the data here. So when you want to see correct data, each employee which location they belongs to. So we are planning to see Adams. Adams belongs to which location? Adams is department number 20. Department number 20 employees belongs to which location? Dallas location. I want to show this Dallas location beside Adams. So you have Adams here. Beside that, you need to show Dallas location here. When I want to show Dallas location here, I'm dragging location. It is not showing. If you want to see the data, you need to establish the relationship between these two tables. So based on which column? A common column. If you want to establish a relationship, you need to have a common column, department number and department number. Select the department number column, drag and drop on department number column. When I go here, so you will see the data. Adams is working in Dallas location. Alan is working in Chicago. Check it. Alan is working in Chicago. Alan belongs to which department? Alan belongs to 30th department. 30th department people are working where? 30th department people are working in Chicago. That is what you are showing here. Whenever you have the relationships, we can show the data from more than one table. I want to show manager name here. For Adams, who is the manager? For Adams, who is the manager? Manager information, manager name is available in manager table. Manager table, manager name is here. I'll go and delete this relationship. For each employee, I want to show manager name. When I want to show manager name here, I'll go to the manager table this time. I'll drag the manager name column. When I drag the manager name column, again, it will not show the data. I'm trying to show the data from three tables now. EMP table, DEPT table, and managers table. Between the three tables, I don't have proper relationships. That is the reason I'm not able to show the data here. So for Adams, who is the manager? For Adams, the manager is, where is Adams? Adams manager is 7778, 7788, 7788. So 7788 is who? 7788 is who? 7788 is Scott. Scott is the manager for Adam. So I want to show here Scott. Beside Adams, I want to show Scott here. If you want to show Scott here, how can you show Scott? You need to have, when I go to the manager table, when I drag the manager name, it is not showing. Why? We don't have relationship. You need to have a common column here to establish the relationship. Manager number and manager number. Drag the manager number, drop on manager number. You'll got the relationship. Now can I see it here? Yes, I'm able to see for Adams, Scott is the manager, right? Whenever we need to create the visuals using more than one tables, whenever we need to show the data from more than one table in single visual, we need to have the relationship between them. If I don't have the relationship, it is not possible to show the data, right? We'll discuss. I said that data modeling, so I just dragging and dropping. We'll discuss about data modeling for 5 hours of time in a detailed way. Fine. So now tell me guys, I'll delete this relationship. I will rename this column department number column to department ID. Right click on it, rename. I'll go and rename it to department ID. Now tell me, so can I go and establish the relationship? Do we have a common column between DEPT table and EMP table? Can I go and establish the relationship here?
Yes, sir, we
Is it
can.
possible?
No, sir.
Yes.
Common
Yes.
values are in both tables. Common values are in both
Yeah.
tables.
We can establish the relationship. So even though it is not that common column means name of the column should be same, the data under that column should be same. So even though when you have a different name, we can go and establish the relationship. Even though if you have a different name, we can establish, but the values under that column should be same. If you see, department number column contains values like 10, 20, 30 and so on. Even department ID column will contains values like 10, 20 and 30 and so on. So even though when there are different names, you can establish the relationship. So look at this. I'm not seeing the data. Even though my names are different, I can establish the relationship. So I can show the data. Common column means not the name of the column. The data under that column should be same. Common column means not the name of the data, not name of the column, not the name of the column. The data under that column should be same, not the name of the column. Common column means not the name of the column. The data under that column should be same. The data under the column should be same. Should be same. So when data under the column should be same, even though when they have different names, we can establish the relationships. We understand why we need to do the data modeling. Once you load the tables, why we need to do the data modeling, we understand it. So now we will try to understand how the majority of data modeling work is done by my Power Pivot itself. How majority of the data modeling work is done by my Power Pivot itself. So I have some settings. So file menu, options and settings, options. In the options, current file, there is data load. So in the data load, there is a section called relationships. 2 checkboxes got selected. These are the 2 checkboxes which are working to get majority of the data modeling work done. So we'll even discuss about the third checkbox. The middle checkbox is there, right? What is this middle checkbox? When to check it, when to uncheck it, we'll discuss now. So how majority of the data modeling work is done is, there are some 2 settings selected. Because of the 2 settings, the majority of data modeling work is done. So what I'll do is, I'll open a new report here. At a time, you can open multiple Power BI reports, guys. At a time, you can open multiple Power BI reports. I'm opening another Power BI report now. So let me write the navigation, file menu, options and settings. In options and settings, you will see an option called options. In the options, you will find an option called options. In the options, you will find an option, data load options. First, you need to go to current file. Current file. In the current file, you will find data load options. In the data load options, data load, you will find a section with the name relationships. Relationships. There, some 2 checkboxes got selected. The 2 checkboxes are helping us to get the relationship. What I'll do is, I'll go here now. In this report, I'll go to the same navigation, file menu, options and settings, options, current file, data load, relationships. I'll uncheck these 2 options. When I uncheck these 2 options, After unchecking, I can bring the tables. After unchecking, I can bring the tables. So when I uncheck, when I bring the tables, you will not see the relationship. Click on new source, Excel, EMP/DEPT, click on open. I'm bringing the tables from EMP/DEPT managers table, press OK. I brought the tables to Power Query. The same way I'll even bring the tables from SQL Server. Click on SQL Server. Let me provide the server name. I'll bring some 3 more tables using this. Go here. What is happening? Let me give the server name. Press OK. Let me bring 3 more tables here. From product database, customers table, product table, and sales table. Click on OK. When I load these tables now, when I click on close and apply, you don't get the relationships. Go and see here. In this report, same tables I'm loading, but when you go to the model view, between the tables you are not seeing relationship. Are you seeing any relationship between the tables? They are independent tables. Why? This time these 2 options are not checked. This time in the data load, these 2 options are not checked. When these 2 options are checked, then only the data modeling work is done, right? On the whole, we understand when they are unchecked, you are not seeing the data modeling work. When they are checked, then only you are seeing data modeling work done, right? Let's understand about the 2 options. Let me close this report. I don't want it. Now, so let's talk about the 2 checkboxes. One checkbox is import the relationship from data source. Import the relationship from data source on first load. Relationships from data source on first load. Whenever you are whenever you are first time bringing the tables, so this option will work with only databases, guys. Import the relationship from data source on first load will work with database sources or relational sources. Database or relational sources. Relational sources. Whenever you are bringing the data from relational databases or relational sources, then only this first option will work. So I'm bringing some 3 tables from SQL Server. That 3 tables already have the relationships in SQL Server. So when you are bringing the 3 tables for the first time to the Power Pivot, what we are asking is bring the 3 tables and bring their relationships also. That is the first option, meaning when you are bringing the tables from Oracle, in the Oracle between the tables, if you have relationship, bring the tables and bring their relationship. Only for the first time you are bringing the relationship. If you have the relationships, bring it. Otherwise, no. So that way, when you bring the tables from databases, so if you see here, these 3 tables we got it from database SQL Server. So might be when you bring these 3 tables, the first option might be working to get these relationships. If in your SQL Server, between these 3 tables, if you have the relationships, that will come automatically. Okay, even these 3 tables you are getting from Excel. In the Excel, between the tables, you will not have relationships. The first option will not work here. And in these cases, the second option will work. The second option is auto detect new relationships once after data is loaded. Auto detect new relationships once data is loaded. Once data is loaded. So you need to auto detect the new relationships once data is loaded. What is the meaning is, once we load, so let's assume I got some 10 tables to Power Query from different data sources. Once I load 10 tables into the Power Pivot, the second option will read each and every table in the Power Pivot. Each and every table, 10 tables it will read. Between the 10 tables, if it find the same name, same column name, it will establish the relationship. So if you observe here, so when I load this EMP table and managers table, it got established the relationship. The second option is reading these 2 tables and it find the same name column, manager. It will establish the relationship, manager. Second option, so I loaded one table from SQL Server, table 1. I loaded another table from Excel, table 2. Even in the table 1, I have a column called ABC. In the table 2, I have a common column, same name called ABC. Even though table is coming from different data sources, table 1 is coming from SQL Server, table 2 is coming from Excel. So they have a same name called ABC here. So even though they are coming from two different data sources, when you have the same name, you have second option, right? Auto detect new relationships that will establish the relationship between these two tables based on this column. Even it will establish the relationship. Okay. Second option will work for every source, every data source, every data source. It will blindly check, is there any common name between the tables? If it find the common name, it will establish the relationships. Sometimes it might be wrong relationship also. Take an example. I have a common name here, ABC. I have a common name here, ABC, but they are not common columns. Sometimes they will not have same data under them. Even it will establish the relationship. So you need to check it. Second option will just read the tables. If it find the same name of the column, it will go and establish the relationship. Then what is the middle option? There is one more option in the middle which got unchecked. Which got unchecked. What is that middle option? Let me go here, file menu, options and settings, options. And the middle option is unchecked. And this is also related to database, guys. This middle option is also related to relational sources. Update or delete the relationships when refreshing the data. When refreshing the data, we need to update or delete the relationship. Take an example. In the SQL Server, when I'm bringing the customers table and sales table, I have a relationship. When I'm bringing customers table and sales table, I have a relationship. First time when I'm bringing this customer table and sales table from SQL Server, I have a relationship. So this option will bring the relationship. Later, there is new data coming in the customer table. New customers will register with us. New sales transactions will happen. I want to bring the new data into the customer table, into the sales table. You need to refresh it. So when you refresh it, so in the meantime, someone deleted this relationship. So there is a new data in the customer table and sales table. I need to bring it to this customer table and sales table. I need to refresh it to bring the new data. And in the meantime, someone deleted this relationship in the database. So when you check this option, when you check this middle option, it will even delete it here. So why we are not checking this option is this, it is not recommended to check this middle option. When you check this middle option, in the future, when you have any changes in the relationship, that changes will come to Power Pivot. Power Pivot. When you delete a relationship here, it will even delete it here. Why? Because this checkbox got selected. Update or delete relationships when refreshing the data. Whenever you are refreshing the data, if there is any changes, do you want to bring it? So it is not recommended, guys. So if you are the one who is maintaining the databases, source databases, if you are the one who is maintaining the Power Pivot model, might be you can check this option. So basically the source databases will be maintained by other team, and this Power Pivot database will be maintained by you. And we don't know what changes they will do in the source database. So we cannot track them. So that is the reason it is not recommended to select the second option. When you select the second option, if there is any changes happen in the source, that will come automatically without your notice when you refresh it. So it is not recommended. That is the reason by default this checkbox is unchecked, guys. I hope you understand these three options. So because of these options, you will be seeing the relationship between the tables. Now, this is at a high level, the introduction of data modeling. So I just give an introduction only. We don't even discuss anything about data modeling. So we call it as OLAP model, right? So in the OLAP, so tomorrow's class is important class. We'll discuss about some data warehousing related concepts. Data warehousing related concepts we'll discuss. So first, already in the initial introduction classes, I discussed about dimension column and fact column. Dimension columns, what are dimension columns? Basically, in the OLTP database, we just call it as tables. But when it comes to OLAP databases, we have a concept called dimension tables and fact tables. Whatever the tables you have in the OLAP model, whatever the tables we have in the Power Pivot, we basically categorize them into dimension tables and fact tables. What is dimension tables and what is fact tables? What dimension tables will contains? What fact tables will contains? We'll discuss. So dimension columns, fact columns. What are dimension columns and what are fact columns? We already discussed. So go through that video. It will help you tomorrow. And tomorrow we'll discuss what is dimension table and what is fact table. And so when you do the data modeling, you'll get schemas. So what is schemas? So we'll discuss some data warehousing related concepts, in tomorrow's class. Tomorrow's class is important. So we'll stop here for today. We'll continue from here in tomorrow's class, guys. Let me publish these notes. Let me pass this video first.
Yeah, Sunil, I'm having a doubt.